Hello 108 students, Mr. McHugh back with you here to wrap up section 3.6. Again, for my class notes, this is 3.5 page 6, but it's the wrap-ups, the new section 3.6 dealing with functions. Okay, so hopefully everybody's feeling comfortable. F of x is a function, and there's various forms that you could find a function at a specific value for x. What if the function is only listed as ordered pairs? It's not a line. And could we find the output for it? So when you see f of x, they say find when x equals 3, what would it be? What's the output? Equals question mark. That's what we're trying to do. Only thing you have here is a set of ordered pairs. So take your time, find when x equals 3. Not here. That's no good. That's no good. Bingo, there it is. So you put f of 3, you came in, you found the x coordinate. The output is what? 1 for y, and you bring it over and you set it down equal to, and you're done. That's all you have to do. Okay, so a lot of these are fairly easy. They're just trying to get you comfortable with knowing the different ways that a function can be represented. It can be represented by a select set of ordered pairs. It can be represented by a line right now that we've been focusing on. Don't forget, in this example D here, we're working with Venn diagrams. Here's the domain, here's the range, and if you're given these sets of ordered pairs now, in an example you see out of section 3.6, you'll see they're going like this. Okay, forgot to put those in my notes. And now the question is, what is f of 3? What is the output of the function when x is the input of 3? What's the output? Okay, that's the challenge. Now, here's what they're giving it to you. It's a visual. So you turn around, find when the domain or when the x, remember, x is your input, y is your output, range is your output. Find x equals 3 and follow the arrow, and it takes you to an output of 5. And what you don't know in this representation is what's the process just up here. You don't know what the process is to go from x to y. Okay, you might be able to figure it out if you plotted them and studied them, but for the most part you don't know. But from here you just jump the line, follow the arrow, and you find out the output is 5, and you put it down and you're done. That's fairly straightforward problems to do. They don't take a whole lot of work, but just understanding the concept, so it's critical. Now here we go. We now have a line. Okay, now what's interesting, they go, what will f of 3 be? When x is 3, what's the output? Now here's how you handle these. Here's your origin down here at 0, 0. Find when x equals 3. 1, 2, 3, x equals 3. What you do is you go vertical, and you find the ordered pair where it hits the line. You come across, and you find the corresponding y value, which is a 4, and that ordered pair is 3, 4. So when x is 3, the output is 4, and there's your answer. Okay, now here's a little challenge for you guys. What if I asked you to figure out what is that process? What is the equation of this line? Now we're going to come up here. I'm going to use a little y equals. Always remember your golden formula: slope, intercept. Always fall back to this. Okay, why do I say that? Look at this graph. Where does it cross the y-axis? Looks like it's at what? 1. The ordered pair would be 0, 1. So class, what is your b? B stands for the y-intercept. Okay, this is a quick review. We use this all the time. You're going to need this for your test. Okay, now we come over, and now we got to figure out the slope. Now this is interesting. You need 2 points to determine the line. Can you do this visually? I want to go from here up to 3, 4. So let's go back. Let's count. Vertical, rise over run, slope. 1, 2, 3. I went up 3 on the vertical. And how many across? 1, 2, 3. I went 3 on the horizontal. Rise over run. 3 over 3. So the slope is 3 over 3. X is your variable. Now let's put f of x in here now. Am I allowed to do that? Yes. No problem. However, what's 3 divided by 3 equal? 1x plus 1. And if I was going to write my final answer, f of x equals x plus 1. What I'm hoping for you to see here is that when you have a line graphed, it is representing the linear equation. They are synonymous. Okay? You can go from a linear equation, graph the line. You can go from the graph and write the linear equation just like we did. Okay? Now, I'm hoping you guys are feeling comfortable with that. It's a key concept here for linear equations. Now, objective 6 here is dealing with, and I use the same equation here. Given an equation of a line, y equals 3 over 3 x plus 1, could you graph it? Now, this is going the reverse direction. Now, we've laid this out already, but 3 divided by 3 is 1, so slope is 1. The y-intercept is 1. Because remember, it's y equals mx plus b, golden formula. Okay, so I like to put a little box around my key pieces of information. Where do you always start with? The anchor point. Y-intercept is at 1. Now execute a slope up 1. Oh, what's the slope? Come over here for a second. Now 1 could be represented as 1 divided by 1. Okay, so let's try. Up 1 over 1, put a dot. Up 1 over 1, put a dot. Up 1 over 1, put a dot. And each of those corresponding ordered pairs, if you stuck them into the equation, would make it true. Okay, we're doing pretty good here. The last thing that we want to cover here is a constant function. That's just a fancy name for a horizontal line. Constant meaning the range, the output is 4 all the way across. So let's look at this. They draw this line, and this is kind of cool. See if you can do this. If they draw this line and they go, what is the equation of this line? You go, well, let's see. Let me think about it. Where does it cross the y-axis? At 4. Is there slope to this? The answer is no. Oh, slope of no. There's no slope. Okay. Slope equals 0. Excuse me. Slope is 0. And where does it cross the y-axis? At 4. Okay, so we could write f of x equals 4 here. Now, if they ask you for the domain, go on the x-axis. This line goes on forever and ever, starting at negative infinity, going forever and ever to positive infinity. Now, what's the range? This is where the word constant comes in. It doesn't change. No matter what point you pick here, any ordered pair here, let's just pretend this is at negative 1, comma, 4. Let's come over here and pick this guy. What would this ordered pair be? Looks at 1, 2, 3, 4, so we're at what? 4, comma, 4. So the range doesn't change, therefore it's constant. Okay, hey, I think we have finished section 3.6, and this is the last section we will have for our first test, so I encourage students to work hard this week, keep up the relentless schedule, keep putting your time in. Keep working on the homework, take your 2 quizzes, and get ready for your test. Okay, Mr. McHugh going to sign off here for section 3.6, so I wish everybody success on your first test. Okay, I'll see you for chapter 4. Okay, goodbye.